Okay, so today we are going to start about Kubernetes. Okay, so we'll see what is Kubernetes. Okay, so why we need Kubernetes. Okay, and how Kubernetes is helping the current ecosystem as well. So nowadays we are doing many deployments in the cloud. Okay, so why we are moving towards Kubernetes and doing already deployments using Kubernetes, everything is. So the prerequisite for the Kubernetes is you should have like knowledge of Docker. Okay, at least if you know, like you should converted an application into a Docker image. Okay, so all the time we don't write the Docker files, but you have that knowledge. An application can be converted into a Docker image. So then we are good to get started with the Kubernetes part.
Oh.
Okay, so if you know there will be some Docker file using which we are going to build a Docker image. So using Docker image, what we are going to run as a containers. Okay, if you have this knowledge, that is sufficient. No matter what, if you don't develop a Docker image, also it's fine. But if you have that understanding using a Docker image, if you can create a container, that is sufficient. Okay. So as I said, all the time we might not develop the Docker images. It might be developed by developers or other persons. So what we need to do is you should take this Docker image and run this as a container. Okay. So while running containers, we do have few problems. Okay. So when there are like multiple containers, right, it becomes difficult. It becomes complex actually to manage and scale containers. So using Docker image, what you're going to run? You're going to run as a containers. Now let's say this is a container. But in organization, there will be not a single container. There will be like multiple containers. Okay, it becomes difficult to deploy the containers if there are a number of containers. To deploy, scale, and manage it becomes difficult. Okay, so that's the reason we are using Kubernetes. So Kubernetes is not any advanced version of Docker. So Kubernetes is the one which can manage the Dockers. Okay. So by definition, Kubernetes we call as an orchestrator. Okay, it's an orchestrator technology that can manage, deploy, and scale containers. If you look at this definition, what it is doing is mainly it is going to take care of the management of the containers part, be it deploying, be it scaling. Scaling is nothing but you are going to bring it up more containers. Okay, let's say there is a container, you are going to increase the containers in n numbers. So basically, whenever you've been asked like what is Kubernetes, right? So basically, Kubernetes is an orchestrator. Okay, so we'll talk about this word, what is orchestrator as well. Okay, if I'm telling orchestrator, we might not be aware of this word. Okay, so we'll see what is orchestrator. So let me type orchestrator here. You will see what we are going to get. So there are some symbols you are going to get when you type orchestrator. Okay, so generally this orchestrator has come from the word this orchestra. So here there is an orchestra that is happening, which is nothing but a music event. Okay, and you could see the one person here in the central place who is going to guide and manage his team. Basically, this person is called as orchestrator. Okay, why is called as orchestrator is he is the person who is going to manage his entire team. Okay, so based on his instructions, this team is going to perform. Okay, so he might tell to perform the event in a high pitch sometimes. Okay, you want to enhance the mode of the customer of the audience. You want to enhance the mode of the audience. So he wants to give instructions to his team to play the music in a very high pitch. Okay, and again they based on his instructions they'll make it into the low pitch as well. So based on his instructions, this his music group is going to perform the event. Okay, so this person is called as orchestrator. Okay, so taking an example from this, Kubernetes also is called as orchestrator. Why? Because so now Kubernetes is going to manage the containers part. Now, if you see right, so Kubernetes is an orchestrator technology that is going to manage, deploy, and scale containers. Let's say we have like a number of containers here. Okay, all these containers can be managed by this Kubernetes. So now what will Kubernetes will do, like if you want to like deploy a containers, okay. So now everything is managed by the containers, by the Kubernetes itself. So now you want to like create a container, Kubernetes will do that. If you want to like delete a container, if you want to scale a container, who is going to do? Everything is going to be done by Kubernetes. So Kubernetes here is called as an orchestrator technology, which is going to manage, deploy, and scale containers. Okay. And why we are going towards Kubernetes is, so we can create, as I said, using a Docker image, you can create containers, but you are going to have like a number of containers. So it becomes difficult to manage the containers. And why? Because let's say you have got an issue inside the container. What you need to do is you need to log into your EC2, then log into your container. Again, you need to come out. Again, you need to log into another container. So these are the things you can do. Okay. But now Kubernetes is designed in such a way that so it does many of the automations. Okay. So whatever we do on the Docker, right? So if you tell Kubernetes, Kubernetes is going to do on our behalf everything. And so Kubernetes in a shortcut, it is also called as K8s. Okay, why it is called as K8s is, so if you see that between the K and 8, okay, have some 8 letters here. Okay, so between K and E, there are 8 letters. So instead of using all this, so in a shortcut, we are calling it as a K8. Okay, and this Kubernetes was actually initially this was a project that was being managed by Google actually. Okay, so Google is calling this as a Borg. So Kubernetes technology is from very long time, older than a decade as well. Okay, but people have been knowing in recent times. Why? Because the Kubernetes technology was being managed by the Google. Okay, but they have not named that as a Kubernetes. They are calling it as a Borg. Okay, it is called as a Borg project. But Google has experience of almost like 10 years in managing and scaling the containers using the Borg. Okay, but why did the world come to know in recent times is, so slowly like companies also like there is a company called Docker which started this containers, so which showed the world that you can create any application as a container. Okay, so applications are going to run in the containers, but companies are struggling to manage the containers. So Docker also tried to introduce one more technology called Docker Swarm to manage the containers. Okay, but it didn't had enough features. So in the meantime, Google also, because they since they have the experience of managing the containers using this project Borg, so they gave this project Borg as a they made it this software as an open source. Okay, so open source means they have gave it to the community. So since companies are struggling to use this or manage containers, right? So Google gave this project to the community. Okay, and now they're calling it as Kubernetes. Now Kubernetes can be used by any companies, and this Kubernetes, right? They have gave it to community, but who is a community here? Okay, so there are several communities here actually who manage the software. Okay, so similarly we have one community called CNCF. CNCF. What is CNCF? Cloud Native Computing Foundation.
Bluetooth ಆಡ್ತಾ ಇದೆ.
Okay, there is a community called Cloud Native Computing Foundation. Okay, so they have given to this community. Okay, now this community is going to manage this Kubernetes software. Okay, since they have given to the community, so now this is being managed by CNCF Foundation. Now CNCF takes the entire responsibility of this Kubernetes software. Okay, and in CNCF again there are many board members. Okay, so there are like board members from Amazon, Microsoft, Google, Apple. So all these companies are also using Kubernetes. Okay, so you from right from Amazon, Microsoft, and Google. So all this, okay, there are many people from these companies who are the board members of the this foundation. So this is an independent foundation. Okay, it doesn't belong to anyone. So why they are like contributing together is, so they want to make this Kubernetes software even more better. Okay, so they have experts from all these teams. So since now they have made it open source, now everyone wants to contribute and make this Kubernetes more powerful, so that whoever is using Kubernetes, okay, it becomes easier to manage the containers. Okay, so now the CNCF Foundation, let me show you that CNCF. So it's not only managing Kubernetes, it manages multiple softwares. Okay, so this is the CNCF Foundation. So if you see how many projects they are managing, like overall like 134 projects they are managing, and there are this many number of contributors. Okay, so it has its presence in this many number of countries. And here are some softwares you might know, or some softwares which you might know in future as well. Okay, all the projects are getting incubated here. Incubated means, so some are in the very initial stage of their development. Okay, so there is something called graduated here. So what is graduated means, these are incubating stage means it has started, people are working on these projects. Sandbox means still they are in very initial stage discussions. So it will be initially in the sandbox, then comes to the incubation once they are working software. So once they have tested all those use cases on the software, when they feel that this product can be used by the customers, this software, so then they make it as a graduated. If it is graduated, companies will start using it. Okay, so we'll see the graduated softwares. Okay, container runtime. This container is one of the container runtime, similar to your Docker. Docker is also a container runtime which can run the images. We have Fluentd. Now we have Kubernetes. We have Prometheus. Okay, so Prometheus is a monitoring tool actually. Okay, so all these are like doesn't belong to anyone. They are independent softwares. They are independent softwares. Okay, so if this software is widely adopted in future, right? So then we might also know about this. Okay, right now all these are in the like graduated. Like Helm is also a graduated project. Okay, what is Helm? So using Helm you can manage your Kubernetes. Okay, you'll see that later. Helm is a package manager for Kubernetes, and this many number of projects they have. So you can see, right, there are members. So all these companies are the members of Kubernetes. Okay, AWS, Google Cloud, okay, Oracle. You can see any top company. Okay, because these are the members of this community. So everyone is going to contribute, and there is a technical oversight committee. So we could see this. This is the technical committee for this foundation. Okay, they are from Apple, Amazon Web Services, Red Hat, and official from Apple, Microsoft, Google, Grafana. Okay. So this is the technical committee, and they'll make the decisions. How should they develop the Kubernetes? And if you want to like write some certifications related to Kubernetes and all, you should come to this foundation. Okay, this is the CNCF foundation that is managing these projects. Okay, you have something called CKA, CKS. So there are many Kubernetes certifications. Okay, starting from CKA, CKAD, and CKS. Okay, so what is this CKS? Yeah, Certified Kubernetes Administrator, and this is Certified Kubernetes Application Developer. Almost both are same. This is more aimed towards developers. Okay, there is CKS as well. So Certified Kubernetes Security Specialist. Okay, if you want to like dig deeper into Kubernetes security, you have this Certified Kubernetes Security Specialist. And there is an official site for Kubernetes, kubernetes.io. Okay, so this is the official site of Kubernetes. Okay, where you can find examples for every object. So whatever we need to create any resource in Kubernetes, so we need to we can use this documentation. Okay, so you have like many things here. How to get started with Kubernetes? Okay, like how to. There are some tasks as well. If you want to try some tasks, there are some tasks that you can try. Okay, how to configure pods, how to do the monitoring, okay, and all. And there are some tutorials as well. How can you manage all this? And as I said, so this is the foundation that is managing CNCF. So this, if you are using Kubernetes, it is actually open source and it is free. But companies never wants to use this open source software. Okay, why? Because companies always they need some support. They need some enterprise support. So as I'm saying, like Kubernetes is a free software. Generally, KX is free if you install and manage everything. But while managing Kubernetes, you might face some issues. Okay. So if you are facing some issues and if you are using Kubernetes for some client, okay, if you are getting issues and you are not able to troubleshoot, okay. So in that case, the project will be halted and that you might face some issues with the client. So that's the reason every company who is using this enterprise support. So what these cloud providers have did is like AWS or Azure or Google Cloud. Okay, so there are like different cloud players. Okay, there are more players as well apart from this, but these are the prominent players in the cloud. Okay, so all this like they are providing their own version of Kubernetes. Okay, in AWS they have something called Elastic Kubernetes. Azure is having their own version of Kubernetes called AKS, and Google is having their own version of Kubernetes. Okay, this is called as GKE. Okay, so Elastic Kubernetes, this is Azure Kubernetes, GKE. Okay, is there any difference between this and this? There is no any difference. It's the same Kubernetes technology. Only if you are using AWS EKS, right? So if you are going to face any issues, okay, from the companies, if you are facing any issues in this Kubernetes, okay, so immediately we can take the support from the AWS. We can contact AWS and take the support from them. So similarly, if I'm facing any issues in the Azure Kubernetes, I can contact my Microsoft Azure team and take support. Why? Because these are the cloud providers we are using. So they offer the enterprise support for us. So generally companies do not rely on employees. Okay. So they should have some reliable support. Okay. If there is one person who is very good with Kubernetes. Okay. So let's say he has left the organization. Okay. They are losing the resource, right? So always they have the required support from the official vendor itself. Okay. So if there is any issue, they can officially contact the AWS team, and the AWS team is going to help to sort out these issues. Okay. So that's why, like every company, because they are managing the different clients, which might be banking, okay, finance, or any other categories. But whatever they face issues, because Kubernetes is a newer technology compared to other technologies, so we might face issues. Okay, so we might not have the required resources as well to troubleshoot all the time. so that these companies uses always the vendor softwares. Okay, so this you need to pay for this, but companies are like interested to pay. Why? Because they want like continuous support from them. Okay, so if you are like purchasing any product, right? So what is that you see like what is the support availability for the product? Okay, how many service centers we do have? Why? Because you need to get that required support via when you face some issues. So similarly, like every software will try to have some enterprise support when it is facing some issues. They want to contact these experts and got it resolved. Okay. So likewise, we have like AWS, Kubernetes, Azure, AKS, Google Cloud. Okay. This is the Kubernetes you need to set it up. So once you have set up the Kubernetes, so to work with the Docker, okay, what you need to do, you need to install Docker so that you get a Docker playground. So you can write all your Docker commands and build, write Docker files, build Docker images, everything. So similarly, to perform anything on Kubernetes, okay, so we should have must, that is this Kubernetes cluster. Okay, on top of my Kubernetes cluster, I'm going to like do the deployments. Okay, create containers, deploy containers, scale containers. So for that, I need this Kubernetes cluster. If the Kubernetes cluster is there, so what I can do is like manage containers, deploy containers, and scale containers. Okay, so let's assume we have set up the Kubernetes cluster. Okay, so what I'm telling, I want to deploy containers where in the Kubernetes cluster, I can deploy my containers. Okay, so for that, what is the prerequisite is you should have some Docker image. Okay? If you have some Docker image, using this Docker image, you will be able to deploy that as a container in Kubernetes. Okay, so if you have some Docker image, so you can deploy this as a container in your Kubernetes cluster. Okay. So for deploying this containers in Kubernetes, what we need to write is, so we need to write some files. Okay. Like how we are writing this Docker compose files, right? So similarly, we need to write some files, and these files are called manifest files. Okay. So this is my manifest file. And why I'm calling this as a manifest file is, so I need to write some file, and the file name should be something like pod.yaml or anything. It could be anything, app.yaml. Okay, it should be in the format of this extension, not YAML file. Okay, only if you have in the .yaml, okay, then only you'll be able to create this as a container. Okay, so now Kubernetes have defined their own version of like manifest files. So there is some standard you need to follow. Okay, every version, API version, every manifest will start with like this. Okay, API version. So this is the syntax. Okay. Next, you have something called kind. So far, I was telling in Kubernetes cluster, you can create containers, right? So I was telling in Kubernetes cluster, you can manage containers, scale containers, and deploy containers. Okay. But in terms of Kubernetes, you actually deploy this application always as pods. You never call this as a containers when coming to the Kubernetes. Okay. Till now, whenever you're running any images, we are running as a containers. Okay. We're calling this as containers. But when coming to the Kubernetes part, always we call them as pods. This application are running as a pods. Okay. Now, when I execute this file, so the application is going to run as a pod. So now this kind will be like a pod object. And I need to give some name of this pod, whatever pod I'm going to create. Metadata. name. So let me say this is like Nginx pod. Okay, I have given the name as Nginx pod. Okay. So next I need to specify the specifications. Okay, that will start from specifications. In specifications, so what are the attributes of your container? So what will have containers will have an image name, container name. Okay. So in container section, I am going to specify hyphen name. Okay. This is nothing but the name of the container. Okay, I'm calling this as Nginx con, which is actually Nginx container. So next I'm going to give image. What image I want to run as a pod? Okay, I want to run Nginx. As I told you, right? So to run any containers, you need a Docker image. Okay, if you have Docker image, then only you can run as a container. So for that, I'm going to specify this manifest file. So you can think of this like some YAML file. Okay, so pod.yaml or app.yaml. Okay, so there is API version, kind, metadata, spec. Okay, so in shortcut you can remember this as AKMS. Okay, A stands for API version, K for kind, M for metadata, S for specifications. You can shortly call this as a spec. So once you have this YAML file and you are naming this file as a pod.yaml, right? So to execute my pod, okay, I should use a utility called kubectl. Kubectl apply -f pod.yaml. So this is how I should execute. Okay. So if I execute this, so what is the name of the pod here? I've given in the metadata Nginx pod. Okay. It will say pod slash Nginx pod created. So this is the output it is going to give you. Okay. So when you give this command, okay. So what it is creating, a pod is being created. Okay. So basically, why we are calling pods? In generally Docker, we are calling this application just as a containers. Okay. But coming to the Kubernetes, we call this application as a pods. But why we are not calling containers? We call containers as well. But your container is going to reside inside the pod. Okay. Let's say this is the pod. So my pod is Nginx pod, right? And what is my container name here? Nginx con. Okay. So where is this Nginx con? It is inside the pod. Yes, yes. You can have multiple containers. But the best practice is to try to restrict with minimum of containers. Okay. But in Max, it will have sometimes two. But try to have it like only one container per pod. Okay. So the name is like Nginx con here. Okay, so there is a pod here. Inside that we are having a container. Okay, but we'll never talk as a containers when coming to the Kubernetes. Always we call as pods only. Okay, but it is actually this container is always within this pod. Okay, so if I want to see pods when I created a pods, so I should use this kubectl utility every time. Kubectl get pods. Okay, so this is the command I use to see to view the pods. Okay, if I'm going to create any pods, right? So I'm going to use this command to see the pods are created or not. Okay, if it is going to give some list of pods, it ensures that. So if I'm getting an output like this, definitely a pod is created. So it is going to give me kubectl some pods it is showing me. Okay. So to create, so in Kubernetes, every application is deployed as How it is deployed? In Kubernetes, every application is deployed as
Pod.
okay. So what is a pod? When they ask you, right? It is like an application. Okay. So you are creating your application as a pod in Kubernetes. Okay. All the applications in Kubernetes are running as pods. So to create this pod, what you need to do is you need to write a manifest file. So we call this as a manifest files, and this manifest files always end with .ml. These files end with .ml. It could be anything. Okay. It could be myapp.ml. Okay. If I ask you to like create a pod, okay, I have used some syntax now, okay, but I don't expect you to remember that. Okay, you can officially use the documentation. So I said, right, there is a good community behind Kubernetes, so they make it easier for the whoever is using Kubernetes. Okay, so there will be some events also you can register sometimes. So there will be like continuous events that are going to happen as well. Okay, so this is the Kubernetes documentation. And since this is a newer technology, so they have made the documentation very simpler. Okay, any user who is going through documentation should be able to understand and can start by himself itself. Okay, so if you like properly have time, if you want to carefully go through the documentation, they have given like everything in detail. So now what I want to is, so I want to get details about pod. Okay, but I don't want to remember like whatever I have written here. Okay, I've written something like API version, kind, metadata spec, everything, right? So I don't want to remember all this. Okay, I have this. I know, but if I don't also, it's not an issue. Okay, so I'm going to type. Okay, where did I type that? So I went to type kubernetes.io. I'm in the home page. Okay, here you type pod in the search bar. So it will give you all the results. So click on this. So this is what they are saying. This is an example of using a container as a pod. Okay, so we have this, right? The following is an example of a pod which consists of a container running the image. Okay, now if you see, so what it has started with the first line API version. Okay, this is the manifest file you write to create a pod. So you have the kind. Why? Because you want to create a pod, right? So you need to give this kind as pod only. Okay, this kind will be changed later. When you do not want to create pods, you want to create some other resources. This kind will be some other things. Okay, what is this metadata? I told you. So metadata is nothing but here if the kind is pod and metadata, whatever you name, you write. So that is going to be the name of your pod. Okay, what is my name of the pod now? Nginx is my name of the pod. Okay, and spec. Okay, this is the specification of your containers. You know the specifications of containers already. Okay, what will container have? An image name. Okay, and what is the container name you want to give to it? Okay, what is the name you are giving here? Nginx only. Okay, we are giving the container name is also Nginx. Pod name is also Nginx. Which image you want to use? Image Nginx so on so. Then they have given like ports. Which ports it should be exposed? Port 80. But if you don't give this also, it's fine. Why? Because Nginx by default it listens on port 80 only. Okay. So you can just copy as it is and save this as a .ml file. Okay, myapp.ml or anything. And how you are going to execute? By using a kubectl command. Okay, so you have something called kubectl utility using which you are going to create the pods. Okay, so let me log into the cluster. So I already Kubernetes cluster is set up. So let me see if I have any pods here running. Okay, there are no pods. Okay, so I'll show you like how to create the cluster. But what it is saying is if I do kubectl get pods, okay, so you should show some pods if there are any pods in my cluster. Okay, I showed you command here, right? kubectl get pods. Okay, so this will display the number of pods that are running inside our cluster, Kubernetes cluster. But I do not have any pods, so let me create a pod. Okay, so I told you what should I write to create a pod. What are the files called actually? Manifest files. Okay, I need to write a manifest file. So I'm going to give us my first pod. So what is the extension? Extension should be YAML. Okay, so YAML, and so I'm inside this file. Inside this my first pod.ml. Okay, I'm going to click on insert. So I'm going to write this. Okay, API version. Okay, so as a shortcut, what I told you, what it is containing. It is containing these attributes, AKMS. Okay, API version, kind, metadata, and spec. Okay, so I'm going to here my official. I will not write again. So I'm just copying as it is. Okay, I'm placing inside this. Or if you want to like change the name of the pods, you can change it. Name of the pods or container of the pod as well. You can change. So I'm calling this container name is Nginx con, and so maybe I'll change the name as Nginx pod. Okay. So these are the names I've changed. Okay, I've saved the file. So using the cat command, I'm going to see whatever is present inside the file. Okay, my first pod.ml. Okay, so I'm having the same things: API version, kind, metadata, and spec. Okay, so this is all about the contents. So as I told you right at the beginning, if you want to like start with the Kubernetes, though you are not aware of Docker, but if you know there is something called as a Docker image. Okay, so this is a Docker image, right? We didn't write these Docker images, but still we are using that, which is developed by some other persons. Okay, if you know that there is something called Docker image, okay, well, then we are good to start with Kubernetes. Okay. So considering this image is developed by some other person, we should be able to deploy the pods. So what is the command I told you to execute? kubectl apply -f. What is the file name? My first pod.ml. So what it is telling? Pod slash Nginx pod created. Okay. So this is a pod it is created, and this is the name of the pod. Okay. So how do I get the pods now? So you're seeing right, Nginx pod. Okay, Nginx pod, and it is running. It is running since 16 seconds. We are able to see the pods. So now, whenever you create a Kubernetes cluster, so we create this Kubernetes cluster, right? So we need, whenever a Kubernetes cluster is created, you have some architecture, okay? So which you need to understand. So your cluster always consists of, so in shortcut, I'm calling it K8s cluster. So your K8s cluster is a combination of master plus worker nodes. Okay, I told you right. So we have already cluster. My cluster is already set up here. So that's why I'm able to create the pods here. Okay, but whenever there is a cluster got created, okay, I'll be having few things. So that is actually called as Kubernetes architecture. Okay, so that architecture is a combination of master plus worker nodes. Okay, so we'll see the Kubernetes architecture. If you know Kubernetes architecture, then only we'll understand what's happening inside the Kubernetes. So this is called K8s architecture. So as I told you, your K8s architecture is a combination of master and worker nodes. Okay, let's say this is my master. and I have like worker nodes. Worker nodes are nothing but your EC2 servers. Let's call this as KX master. And my KX master has multiple components. Okay. So we have few components like API server. I have API server. Okay. I have scheduler. I have controller. And I have one more component called HCD. Okay. So these are the four components I am going to have or being present as part of the Kubernetes master. Okay. I have this API server. Scheduler. Controller. And HCD. Okay. So these are the four components I have as part of the Kubernetes master. And what are these? These are like worker nodes. So there are like four worker nodes. Okay. So these are nothing but you can think of like just EC2s. And there will be something running on our worker nodes as well. Okay. We have some component called kubelet. There is something called kubeproxy. And there is another one called container runtime. Okay. So as a shortcut, I'm calling as CRT. Okay. CRT is nothing but container runtime. So these are the things that are present on your worker nodes. Okay. So in every worker node, you have CRT, kubelet, and kubeproxy. Okay, we have all these components. Okay, so where are these present? These are present in your worker nodes. Okay, so this is actually happening at the back end. Okay, so you know, like this is a master and these are a worker nodes. Basically, what is happening is, so I was hitting one command, right? I was hitting one command called kubectl apply -f, and what was my file name? My first pod.yaml. Okay, so this is the command I used to create the pods. Okay, so when I'm executing this, so basically in the back end we don't know what happened. Okay, but what is the response it returned? So it just gave me like cubes get when I did kubectl apply -f pod.yaml. So it has given me the pods. Okay, so I could see something called pod/nginx pod created. Okay, so it has written me that output. Okay, but we'll see what had happened in the backend now. So basically, kubectl is an utility which you can use to interact with your master. Okay, so when I executed this particular command called kubectl apply.yaml, so this command is actually hit this particular API server. Okay, whereas this command has gone is this command has hit my API server. Okay, so in the Kubernetes we have this master and worker node already. Because my cluster is running, it will have master and worker nodes. So in master I have few more components called API server, scheduler, controller, and etc. So now my command has went to API server. My API server will know that okay, there is a request for pod creation, and it will inform the scheduler. Scheduler, can you schedule the pods on available worker nodes? Okay, these worker nodes are nothing but the servers we have. Now this scheduler, what we'll do is, we want to schedule one pod. Which pod? Nginx pod. Okay. It will see how much resources are required for running an Nginx pod. Okay. So my scheduler will check. So how many resources is my nodes are having. Okay. So and it will check which node has sufficient resources for my pod. Okay. My scheduler is going to place this pod on any one of the worker node. Okay. So this is where my pod is being placed. Inside the pod, what are the specifications we have? Like we have given which image and all. Okay. Now kubelet will see what image is as part of this pod, and it will pull that image and runs as a container. Who is going to run that? Kubelet. Kubelet is an agent. Okay, that is running on the worker node. Here, just the pod was scheduled here on the worker node. Now kubelet is trying to see this pod specifications, and it will see like this .aml. Okay. So this is the .aml file, right? So whenever I'm doing like kubectl apply pod.aml, okay. So in Kubernetes we have like architecture, master and worker node. So whenever I'm hitting this command is going to talk to one of the component in the master, which is API server, and this is the brain of the master. Okay, it is a very important component, Kubernetes master. So my command will say, okay, there is a request to the API server. Now API server will take that and inform the scheduler. Okay, scheduler is another component in the master. Now scheduler will check which node has sufficient resources. It will go to this node. If this node has not sufficient resources, it will not allocate the pod here. Okay, it will go to another node. If this node is also not having sufficient resources, it will go to the another node. Node is a server. So now the pod is allocated here. Okay, so on every worker node, you are having something called kubelet. What is this kubelet doing is, kubelet is reading your pod specifications and understanding there is some another image in this pod which I should run as a container. Okay. Now there is a container running in my pod. Okay. Now kubelet, what it does is, once the pod is created, it is going back and informing the API server. Okay. It is informing the API server saying that the pod has been created. Okay. So now what API server will do is, it will again take that value, whatever the kubelet has told, it is storing that value in the etcd. etcd is basically a database. It's a key value store database. Okay, all the data is stored in this etcd database. So you have something called pod created, right? Pod Nginx pod. So it is telling there is an Nginx pod created, and we are adding that entry in the etcd. Okay. Now API server will inform the customer. And how will it inform is, because the customer has given this command, right? kubectl apply -f pod.aml. So from API server, it is returning another output. So saying that pod/nginx pod is created. Pod/. Okay, but behind these things, so many things had happened. Okay, so when I created AML file, let me delete my pod and create again. I'll go to my cluster. I can delete my pod as well. So if I do kubectl get pods, okay, I have a pod running here. I can delete this pod as well. Kubectl delete pod and the pod name. Okay, I have deleted this. So to create a pod, we need a YAML file. Okay, cat my first pod.aml. So this is the YAML file I have. So now if I want to create the pod, what I need to do? kubectl apply -f my first pod.aml. But it has quickly given me pod/nginx pod created. Means it has happened so faster inside the architecture. Okay, inside the master and worker, so many things happened very faster. Okay, but what it had happened is, so as soon as I given this command, so in the Kubernetes master, it is talking to the API server, and my API server is informing scheduler. My scheduler was scheduling that node on one of the worker node. Okay, and once it is scheduled, there is some agent called kubelet. Okay, that kubelet will read. So in this pod specifications, there is some image I have specified. So it is going to check in the pod specifications what is the image present. So it uses that image and runs as a container. Okay. So that is being done by kubelet. Now, once that is being done, so it informs back to whom it does inform kubelet. It informs API server because it is the main component in the master. Now API server will do what it will do is it will talk to this HCD database and add the entry. Okay, this is HCD is nothing but it's a database. It will store the whatever actions are happening inside your Kubernetes cluster. All the activities are recorded here. The state of your Kubernetes is stored here in the HCD component. Okay. Now let's go through few of the K8s architectures. Okay, now you could see this, right? This architecture. So your architecture consists of master and what are these? Worker nodes. Worker nodes are nothing but the servers. Okay. So in master, what are the components you have? API server, scheduler, controller, and etcd. Okay, which is a database I told you. And on worker nodes, I have like these pods are running. Okay, you can see right inside the pods you have multiple containers. Okay, there can be like multiple containers running inside a pod. Okay, and there is a kubelet running kube proxy which is also there as part of the worker. So they have not defined like container runtime. Okay, so there will be a container runtime as well. So which kubelet uses and pulls the image and runs as a container. So what are the commands we are passing from, as a user? We pass kubectl apply pod.yaml something. Okay, so that command is being talked to the API server. So then it will inform the scheduler to please schedule this pod on the worker nodes. It will see whichever worker node has sufficient resources. Okay, and then it is going to assign the pod on the specific worker node. Now this worker, once it is assigned here, my kubelet will see the pod specifications and it pulls the image. Okay, and then informs back to the API server. Now we could see who is talking to the HCD. So only API server can talk to the HCD, not any other components here. Okay, so only your API server has the permissions to talk to your database. It will add that entry saying that the pod has been created, Nginx pod, and API server informs the user saying that pod/Nginx is created. Okay, so as I created my pod here, so I can also like get the details about the pod. Okay, kubectl describe. If I want to get more details about the pod, okay, so I'm going to use kubectl describe pod and pod name. What is my pod name? And then okay, so kubectl describe pod and the pod name. So here I can see like get more information about the pod which I have created. Okay, so what is this pod name? Nginx pod. So when it was created, like so and so. So every time when you create a pod, it will have an IP address. Okay, this is the pod IP address. So which image it has used? Nginx image. So on which port it is running? Port 80. And so coming back to the this here. Okay, you see here, right? So what it is, there are some actions that happened actually. You could see all the events here. Okay, all the events means whatever is happening across your cluster, right? Okay, while the pods are creating, deleted, every action is scheduled present in this event section. Okay, now, so if you see here, what is telling default scheduler successfully assigned on a particular node. So who is assigning this? Scheduler. Okay, so scheduler successfully assigned the pod on the particular worker node. Okay, so it has tried to assign on some of the worker node, but it couldn't do. Okay, then so there was some issue that happened. Maybe I'm running two worker nodes, so one is not working here. So now, what is this kubelet is doing? Kubelet, once the pod scheduler is assigned the pod on one of the worker node, what is my kubelet doing? So kubelet is pulling the image. Okay, so it is pulling the image, but already have Nginx image. Previously, I have used this image, right? Now kubelet is going to create the container and start the container. Every actions are done by the kubelet. Okay, so the kubelet is an agent present on your worker nodes, which is responsible for creating the images from the images as a container. Okay, and you could see here who is assigning the pod on the worker node. Scheduler. Okay, scheduler is a component in the master which is going to assign the pod on the worker node. Okay, so I can see how many nodes also have on my cluster. kubectl get nodes. Okay, I have like two worker nodes. So these are the two servers. Means in my architecture, I have two worker nodes, worker one and worker two. Okay, and depending upon our worker nodes, we call that as the size of the cluster. So my size of the cluster is 2 because my worker nodes are 2 right now. Okay. So whenever you're creating the cluster, we are not created cluster today. We'll create the cluster tomorrow. So whenever we are creating the cluster, it will ask how many worker nodes you need. So based on the cluster size, okay, you are going to define. If you need 4 nodes as part of the cluster, you give the cluster size as 4. Okay. Or if you need just 2, cluster size is 2. So if you understand this architecture only, you will be knowing what is happening in the backend. Okay, but if you enter just commands, you know, okay, you are giving some kubectl apply -pod.yaml, a pod is created. Okay, but in the backend, what is happening is, so whenever you give these instructions to a master component, okay, which is like API server, it is taking your YAML file manifest, then it understands a pod should be scheduled, so it will give to the scheduler. Now scheduler will place this on the one of the worker node. Okay, as soon as it has placed the pod, kubelet will check, okay, what is the image it should pull as a container. Once it has pulled, it will inform back to the API server. Now API server will store that information in the HTTP and sends back the information to the user who has used. So what is kubectl here? Kubectl is a command line utility to interact with the Kubernetes cluster. Okay, so every time if you want to interact with the Kubernetes, right, we want to use this kubectl command. So you could see here as well, right? So it's a command line utility here. Okay. So why they are using this? There is an user interface as well. Some applications gives you some web console. From web console, also you can interact with the components. Okay. But most of the times we do with the command line itself. So this is the tool we should install to talk to the Kubernetes. So this is the command line utility, and again they have this worker nodes, kubelet, proxy. They have this container runtime. Their container runtime is Docker. Okay, so they have now recently, other than Docker, they are using another container runtime called as Container D. Okay, so when I went to this cloud computing foundation, right, we have seen few things. This Container D. It's an open and reliable container runtime. It is also used to run containers similar to your Docker. Okay, actually Docker should be also called as a container runtime, not container. Okay, because the company name was Docker, people started simultaneously using Docker or container. Okay, but it is just a container. Docker is nothing but the company's name. Okay, Docker is the container runtime. Okay, they are using container runtime as a Docker. So now they are using this company, okay, which is called as a container D. So using which we can also create containers, and it uses a container runtime called container D. Okay, likewise we have like multiple container runtimes. Okay, we have like see Docker is a container runtime. Okay, so Creo is a container runtime. So we have all these container runtimes. We have one more thing called Rocket. So it is also a container runtime. So it can use any container runtimes. So what is Kubernetes here? So Kubernetes is a powerful orchestration technology, okay, for managing and running containers, okay. And it is also known as Gates, and it is an open source platform, okay, for running containers application in production at scale. Means you can use these applications in production as well, okay. So as we have seen, this Kubernetes originated from Greek, which means helmsman or pilot. So this logo you are able to see, right? So it's like you used to drive the anything, like it's a like steering actually, okay, which can drive a vehicle, something like that, okay. So which is calling as helmsman. So Google open sourced this project actually in 2014. So Google gave it to the community in 2014. Slowly by 2017, it is actually picked up. Okay, 17 or 18. Okay, so this is the architecture, whatever we have seen as part of the Kubernetes architecture. Okay, these are the master components and these are the worker components. Okay, you have like all these components in the master. Okay, etcd, scheduler, controller. Here you have kubelet, kube proxy. So these are the components of your worker node. So similarly, you can have your container runtime. So what is a pod? Pod is the smallest unit of deployment. Okay. So by default, this is the definition that is given by the Kubernetes. Means if you want to deploy anything, so this is the smallest unit using which we can deploy. So in a normal saying, like if you want to deploy an application, okay, so you can use the pod to do the deployment. So how do we create a like first pod? So what do you need to write? So you need to write an YAML file. Okay. So what is this YAML file? It can be anything like a pod.yaml. Okay. You have these specifications as part of, right, this API version, kind, metadata, spec. So these are the part of your pod.yaml. So if you enter this command, so where this command is going to talk to it is going to talk to the API server. Where is your API server? In the master. Okay. So there are some things that happens behind this, and it will send you the response saying pod/nginx created. Why? Because your name of the pod is nginx. Okay. But in the backend, we have seen what are the things that are going to happen. So if you want to get the list of pods, okay. So you can use kubectl get pods. You are going to get the list of the pods, and you are also want to know, like there are worker nodes running, right? So there are two worker nodes. You want to know where is my pod running on which node. Okay. So I can use kubectl get pods -o wide. Kubectl. So get nodes is how many worker nodes I have as part of my cluster. Okay, I have two nodes. Okay. So now the command was to see where is my pod running on which node. Because my scheduler will schedule the pod on any one of the worker node, right? So now I want to see where it is scheduled. Okay. So kubectl get pod -o wide. So where it is running on this worker node.
Node 1.
Okay. So we have a one node here with the name with the IP address 192.162.57.54. So this is where my pod is scheduled. Okay. Nginx pod. So this is how you can know like on which of the worker nodes you have your pods. And in case you want to delete the pod, you can again use kubectl delete pod and the pod name, okay, using which you will delete the pods. So we have seen like how pods are created, right? So we use this command kubectl apply -f. What is this? Manifest files. So it can be anything, app.ml, pod.ml, it could be anything. So this is how you are going to get the response from the API server. So there is another way. So what I've seen is like declarative way. So writing the manifest files. Okay. If you want to like create a pod with just in imperative way, you can just use this command kubectl run pod name, kubectl run pod name, and what image you want to use as part of the pod. Okay. In simpler way, you can run this as an imperative way. So in Docker also used to use Docker compose to create the containers. Also you can use docker run command also to create containers. Okay. So but this is easier, but we will not use this imperative way. Okay. But quickly you want to run a container. Let me show you. Instead of that, you want to just use kubectl run and create a pod. Kubectl run. So you want to give the pod name. Okay, my pod. Hyphen image equal to nginx. So now also you created a pod. Okay. So what is the pod name here I have given? My pod. Okay. Quickly, if you want to spin up a pod without an YAML file, you can use the imperative way. Okay. So there is an imperative commands as well. So you can use Kubernetes imperative commands. I mean, you don't write any YAML files here. So they have given some commands here. So if you are creating the pods this way, this is called actually declarative way. Okay. So using manifest, if you are creating pods or any resources, it is called as a declarative way. Okay. But if you want to find, you can find some list. So Kubernetes imperative commands. Okay. If you want to create services, you can use kubectl create or kubectl create ns like this. Okay. Which we'll see later as well. But we'll never use mostly the Kubernetes imperative commands. Okay. Always we use like YAML files only. Okay. So these are called declarative. There are two ways using which you can create resources in Kubernetes. One is declarative, one is imperative. Okay. Declarative is like you're writing your manifest files. Imperative way is using your run commands. Okay. So like that, using this just the command you are going to create the. So why don't we use this? Because if you are writing using manifest files, we can store this in the GitHub for a later usage as well. Okay. I have my backups, everything. But if I want to create like every resource using a command, it will be very difficult for me. Okay. If I'm keeping everything as part of the YAML files, I can easily bring it up using a single commands. Okay. But every time I need to create pod like this means I need to execute so many commands. Okay. So that's why we keep as part of the YAML. So the another advantage of keeping the this in the YAML file is you can keep these YAML files as part of the GitHub. So whenever you want to deploy the same pods in different servers, you can use the same YAML files. Okay, and you can reuse. So if you are keeping it in the GitHub as well. Okay, so this is how we have created the pods using the imperative. So if you all want to like YAML the pod, so means you want to create the pod using the YAML. Okay, in that case you can use like this kubectl apply -pod.yaml. So this is using the YAML. Okay, so but if you want to create pod using the imperative way, So you can use this. So we have seen like describe the pod, right? So to get more information about the pod, what we have used, kubectl describe pod and the pod name. Okay, so these are the topics which we haven't discussed today. Okay, maybe we'll see tomorrow. Or so if you see, these are the pods. Okay, and where are your pods running? On your
working notes.
worker nodes. Okay, and what are pods containing? Containers. Okay, so these containers, you can see there is a single container inside the pod here. There is a single container inside this pod. Again, here you have like multiple containers inside the pod. Okay, so there can be multiple containers. So these are like nodes, they have pods, and inside you have containers. Okay, now we could see right on the, these are the worker nodes. There is a pod inside the container now. Okay, so and there is a kubelet agent which is on the worker node, which was responsible for making this container run inside this. Okay, I'm going to stop it here. Okay, so tomorrow we'll create a Kubernetes cluster. So once we have the cluster, right, so we can create this pods, whatever we discussed today. Okay, I'm stopping it here.